Good afternoon everybody, I am Monalisa Chatterjee from CMP MS department working under the supervision of Dr. Manoranjan Kumar. Today I am going to discuss about the quantum phase diagram of ferromagnetically coupled Sutherland model. This is our model Hamiltonian where J is representing the nearest neighbor interaction and the next nearest neighbor interaction is represented by the J prime. In the phase diagram it is seen that dimer and the nil order phase are formed at the two extreme limit of the interactions. The main question arises regarding the nature of the intermediate phase. Is it forming the helical order or it is forming the placket singlet in the intermediate region? In 2013, in this paper, it was shown that placket phase is formed between the dimer and the nil order phase. And recently in 2021, Sandwick showed the existence of the spin liquid phase between placket and the nil order state. So this is the phase diagram of the antiferromagnetic Sutherland model. Now in this project we want to see what will be happened if we apply ferromagnetic nearest neighbor interaction instead of antiferromagnetic nearest neighbor interaction. Let me discuss about this material briefly. Here X is representing the halide ions and the interlayer is forming by the interaction of copper ion with these halide ions and it is forming the magnetic layer. This magnetic layer is well separated by double layer perovskite slabs and this structure can be extended in 2 dimensions. This material can be synthesized by ion exchange reaction method. In this paper, the chi value is plotted with various temperature and it is showing that at very large value of the temperature the curve is fitted by this equation. This is the spin susceptibility equation for isolated dimer where delta is giving the spin gap existed in the system and they have predicted the value of delta around 226.5 Kelvin, but the main discrepancy is coming near the peak region and also 1 by chi versus T graph showing that at very large temperature there is a discrepancy between the experimental and the theoretical values. Here they wanted to show the Q dependency of the intensity. The intensity graph is showing the oscillating nature and they have fitted it by this equation where F is the amplitude and the value of R they have obtained is around 8.8 Armstrong, which is far longer than the first nearest neighbor distance. So from these observations they have concluded that very large frustration is induced in the system and that's why it is forming the square lattice with nearest neighbor interaction as ferromagnetic type. But the main discrepancy is coming in their result because they have predicted that the nearest neighbor interaction is ferromagnetic, still they have shown the existence of a finite gap in the system. So by observing this type of discrepancy in this paper they have tried to reinvestigate this model. So first they have done the neutron scattering experiment. Here intensity is plotted with various energy and it is shown that with application of magnetic field around 11.5 Tesla the one peak structure is splitted into 3 peaks and the Q dependency is showing that there is a prominent peak around 0.5 and this curve is well fitted by this equation where the value of R is around 8.42 Armstrong and so this value is again very large than the nearest neighbor distance. After that they have tried to see the structural parameters and from their observation it is clear that this NbO6 octahedra is now tilted from their original position and this influences the locations of chlorine and copper ions. So the chlorine ions are now shifted around the towards the A and B direction and that's why the total structure is now distorted. After that they have calculated intradimer distance angle and the coupling ratio for various exchange interaction paths and it is seen that for the J4 paths that means CU, CL, CL, CU cases the intradimer distances is largest and the strength is also largest and the corresponding energy is minimum. That's why they have concluded that in these cases the model is no longer the square lattice, it is forming distorted Sutherland model where the dimer is formed between nearest between two copper ions which are the fourth nearest neighbor between each other. So by observing this new structure, in this paper they have tried to plot the quantum phase diagram theoretically. They have taken this type of model Hamiltonian where Jx is representing the interaction along x direction, Jy representing the interaction along y direction, and J is the diagonal interaction. And by applying exact diagonalization and the mean field theory, they have plotted this phase diagram, but the limitation of their calculation is that they have only taken the system size as 24, so there is finite size effect, and also they have only predicted the existence of spiral order, but they didn't give the confirmation of the existence, or they didn't able to show the spiral order in the system. By observing these types of limitation, we have started to investigate this model. Here we have taken the same Hamiltonian and we have applying the DMRG. We have started our calculation with 4-leg geometry and extended up to 8-leg geometry. We applied PVC along y direction and our x direction is open. We have first calculated the spin-spin correlation. Here different side is taken at the mid of the system because in order to reduce the edge effect, and with respect to this reference side we have calculated the correlations along the length, along the width, and also along the upper leg. And it is showing in the figure that for the 4 cross 12 leg geometry keeping fixed J2 as at minus 0.4, we have seen that for various value of J1 various kinds of spin correlations are observed in the system. When J1 is very small, all values are positive. When J1 is very large, there are some positive value and some negative value, and when J1 equals to J2, all the correlations are 0. So by observing this various pattern of the correlation functions, we have figured out 6 type of configuration. First one is showing the stripe order when the antiferromagnetic alignment is observed along the leg and the ferromagnetic alignment is observed along the width, and the stripe 0 pi is showing just the reverse situation. We have also observed the existence of x spiral and y spiral, and perfect dimer here is formed, and we have also got the ferromagnetic alignment. Here we have shown few results obtained from 4-leg geometry. The figure 1 is showing the correlation along leg, figure 2 is showing the correlation along width, and the correlation along the upper leg is shown in figure 3. So in figure 1 it is showing that when J1 is very small, then the black curve is showing all the values are positive, whereas the figure 2 is showing that the positive negative value, that means it is supported that stripe 0 pi order is existed in the system. When J1 is large, then we have seen that up down alignment along the leg, but along the rung it is showing the ferromagnetic alignment, that means it is forming the stripe pi 0 in these cases. And we have also seen that the correlation for when J1 is equal to J2 is 0 along the leg and along the width also, but along the diagonal it is forming the value 0.25. So perfect dimer is formed in these cases. We have also shown the existence of the spiral order, which is existed between the stripe and the perfect dimer region. Our spin-spin correlation is following exponential decay, so very short range order is existed in the system. Here we have compared the result obtaining from 4-leg, and we have seen that it is greatly matched with the 8-leg results. Here we have shown various correlations pattern which is obtained by applying 8-leg geometry, and it is also suggesting various types of phases exist in the system. So after observing the spin-spin correlation and magnetization, we have finally plotted the phase diagram. It is showing various kinds of phases existed in the system: stripe order along both directions, spiral order along both directions, perfect dimer, and the ferromagnetic alignments of the spin. So this is our conclusion. We have started our calculation with 4-leg geometry, and it is well matching with 8-leg geometry's result. We have constructed the phase diagram which is consisted of various phases. We have also give a confirmation of the existence of spiral order and very short range order exists in our system. Thank you for your kind attention.